Good morning. Please welcome our next speaker, Hansa Kral, who will be talking about designing a Pythonic interface.
Thank you. Hello and good morning. As has been said, my name is Hansa Kral, and I would like to talk to you about designing a Pythonic interface. And the better title probably for my talk, which only occurred to me later, is an illustrated guide to this. Because you all know what happens in Python if you type import this. You get sort of a mission statement, a set of guiding principles of Python itself, and for Python code in general, of how it should look and how it should behave. And that is what really this talk is about, how to take those principles and apply them to designing an interface to a foreign system. So first, a little motivation. What brought me here, and that's Elastic, the company that I work for, where I actually create a Python client for Elasticsearch. It's a search and analytics engine, and it's not at all important for this talk. But what is important is we'll be using it for some examples. So don't be alarmed if you see some JSON somewhere in there. So let's get to it. So import this, the Zen of Python. As I said, a guiding set of principles, and I always like them. You know, they sound cool and they really make sense to me. But I always struggle a little bit. How do you actually apply them? How do you apply them to code? Does that actually translate? Does it make any sense? In this talk, I would like to share how I actually discovered, or maybe I just rationalized it away, doesn't really quite matter probably, how I discovered how I use these principles when I design a new API and how I actually apply them in a real life. And because I actually said I a lot, just in the past sentence, a little bit of disclaimer is in place. This is obviously my personal opinion. This is what I find that works for me. And also, some of you may have seen my code and documentation or lack thereof. So please do as I say and not as I do, because I certainly am not perfect, and my code definitely reflects that. So, any good talk begins with the definition, right? So API. What do we mean by API? What do we mean by an interface? So for this talk in particular, we mean a Python API, an interface to a foreign system. So something that will allow you to talk to a third-party system, in our case, Elasticsearch. And this is something that typically you don't need in Python. I mean, Python is Turing complete, right? You can write absolutely anything in Python, so you don't need these interfaces. You can communicate directly, especially in case like Elasticsearch, which actually just speaks HTTP and JSON. You can just use requests or any other favorite HTTP library and talk to it directly. But that's not really what you want to do. You don't want to keep rediscovering the wheel, and that's why we have APIs. Somebody created an API to make things simpler, to hide away the complexity. So you might talk about an API in this case that it is a service for code, for the real code, for the code that actually does the work, for the application code. And there is a huge difference between the code of the API and the code of the application, the real code. Because the API doesn't really apply for a specific use case. Because the API doesn't know anything about the real code. So it can be used by many different people in many different organizations, and hopefully it will be. Like, that's sort of what you hope for when you create an API, right? That people will use it, that it will spread. So the application, on the other hand, is always written to solve a specific purpose. So the API fulfills a contract for that code. And the contract can be either explicit or implicit. It can either be explicit via documentation. You can document the contract. You can say, these are the methods, these are the responses, and that's probably something that you should have either way. But you can also have sort of an implicit contract, a cultural one, if you please, which sort of makes the API behave as you would expect it. It should be natural, and you should be able to rationalize and to think about the API and avoid any surprises. That's sort of what you want for the users of your API, to be able to use it as if it were part of their system, to not having to think about it too much. But first of all, we need to address some of the issues with the API. The first one is that the API is vaguer than application code. And yes, I actually had to look this up. It is an actual word. I wasn't sure for a while. It is actually accepted by the dictionary. Okay, the British protest again. What a surprise. So it is a lot vaguer. It doesn't really know what it's going to be used for. An application code is specific. It solves a problem. You create an application to scratch an itch, to deliver a solution to your customer, or to power your product. But your API can be used in so many different ways that you never know, and making any sort of assumptions on how your API is going to be used can be very difficult. So ultimately, the API is just a tool, and you always have to keep that in mind, that it's a tool that that anyone should be able to wield to create. And it's a tool to simplify access. And to simplify access, the crucial part there is to simplify. And we have our first line from the Zen of Python. Simple is better than complex. Complex is better than complicated. And that is the purpose of the API, to actually facilitate this line, to take something that would be complicated, opening a socket, creating an HTTP header, sending it over, creating a JSON body, sending it over, receiving some responses, determining if everything went okay, etc., etc. That's definitely unnecessarily complex. And that applies to anything. If you want to work with HTTP, you also probably wouldn't start with raw socket, but you would use something like requests, a well-designed library that just gives you exactly the functionality that you need in a way that you can use. So that's what simplifying access is about. It's about hiding complexity. So this is a query to Elasticsearch. Don't worry if you don't understand it. Essentially, what this is I'm looking for something that matches Python in the title. It must not match beta in the description, so I'm looking for release. I'm filtering only those packages in category search, and I want to do some aggregations. I want to see the distribution of tags and the maximum lines. So just some query, assuming a data set, and that query is not important. What is important, that there is a lot more things on the screen than what I just read. And I read all that this does. In the end, it just prints it out with the relevancy score and the title of the document. So there isn't really a lot of things actually going on, but there is a lot of things that are being typed there. So how do we simplify that? How do we hide the complexity? Well, this is what I came up with. And I'll spend the rest of my talk explaining to you why and how I came up with that. I already see some people cringing because they've used this code before. That's never a good sign. Okay, so in this case, I tried to extract only the things that are relevant, only the stuff that I actually read, only the action items, not really all the gravy, all the boilerplate code. And to me, that's what an API should do. It should hide away all the boilerplate while leaving all, and that's the crucial part, while leaving all of the important parts. Not just some, but all of the important parts. And that's sort of the embodiment of another line of the Zen of Python. Be explicit. Explicit is better than implicit. So while I hid away a lot of the complexity, I didn't hide away the crucial parts. And that's sort of the very important decision, what to hide and what not to hide. Because you can always go the next step. You can always imagine how you could make this even simpler. For example, just creating some sort of query language where you would just say the 3 words and say this should be there, this shouldn't, and this must be there as a filter, etc. But at that point, it's getting hard to read, it's getting hard to get into, it's getting harder to reason about. So be explicit. And in the word of code, what that means is when you're hiding complexity, do hide the mechanics. Do not hide the meaning. So if you're doing an HTTP request with requests, you still have to know what is the difference between get and post and put. That is the meaning. That is not the mechanic. What you don't really want to know about is about sockets and parsing of HTTP headers. You just want convenient access to it. So that's mechanics. That's something that you should hide away. That's something that's not specific to the problem. That's specific to the implementation. So this is sort of how you draw the line, what to hide and what not to hide. So if we look into the original code, so you see I've highlighted the parts that are actually just the mechanics. Sorry about this. Where you see that I have a bool query which has 3 branches, must not, and filter, and those can be very confusing. And also they don't matter. They don't carry any information. They're just a way that the query DSL, the language that Elasticsearch uses based on JSON, how it expresses how to combine other queries. It is the how. It is not the what in this case. This is not what you want to do. This is how you want to do it. And this is something that I don't want my users to have to know in order to use my library. However, I am fully comfortable in forcing them to know all the rest. So that's all that I hid. I never hid the match or the term query. So this is the meaning. You still have to know what is the difference between a term query, a match query, and how to do a negation. In this case, the negation is in Python, so we should all be familiar with it. But that's the meaning. That's the same as requests still asking you to know the difference between HTTP GET and HTTP POST. If I hid this away, it would make a lot of people's lives easier. But then you would have a very narrow ceiling after which there is nothing you can do. And also, this means that I don't have to teach my users everything. They can just use the skills that they already have by understanding the query DSL of Elasticsearch itself. On the other side, with the request example, people understanding HTTP and HTTP methods. I don't have to reinvent that. It's already there. People already know it. So all I have to do is give them access to it. And a similar thing goes for the results. Here I have some crazy dictionaries with underscore source and underscore score. That can be a little difficult, and again, it just bears no meaning. 90% of the time, people just want access to the fields, or alternatively, the meta fields. So again, just abstract it away, hide it, and also provide a more convenient way to access it. So instead of square brackets and quotes and underscore source in every single line, just use dot title. So this is something that just simplifies the mechanics while not actually taking anything away. And also, it's good to fully admit to the leakiness. So in this case, still showing all the different query types, all the different aggregations. You see that I still force the users to name their aggregations just as they would in the query DSL, so they can then get them back in the results. It's a very thin, abstract layer. Exactly because I want people who use Elasticsearch in some other context, maybe from another language, maybe directly through the browser or the command line, I want them to be more effective. I don't want them to have to learn yet another tool to do what they already can do. And also, once they learn this tool, I don't want that to go to waste if they have to change to something else, or if they have to ask for advice online. If I created my own complete query language and then I had to ask someone on the internet, so this is what I'm doing with Elasticsearch, can you help me? Well, the answer will be no, because nobody else will understand that query language. So the standardization, the leaky abstraction here is very, very important and very deliberate. And it is also because, well, I'm lazy and I don't want to rewrite the entire documentation of Elasticsearch, what query does what. Here's that too. So that's sort of another guiding principles. Be familiar. Present to the user something that they know from somewhere else. Whether it's a universal concept like different types of HTTP requests or different types of queries in Elasticsearch, or something that's already been used before. So don't be afraid to just copy shamelessly from stuff that you've seen around. So essentially you could sum up the library that I created, the Elasticsearch DSL, as a combination of these two things. The second one we've already seen. That's just using the raw Elasticsearch API. And the first one, well, that's Django query sets. So that I borrowed some patterns from Django, some patterns from Elasticsearch, and combined them together. So for example, the chaining, the fact that every additional filter, whenever you add a filter, you will get returned a copy of the query that comes from Django. That's something that people expect, or at least are familiar with. And then you have all the different query types that come from Elasticsearch. So Python people who want to use Elasticsearch should be familiar with both of these concepts, and the API should feel homey to them, should feel familiar. They shouldn't be surprised, and they should be effective. So once I did that, I turned into to another rule: be consistent. Once you figure out your approach, stick to it. So special cases aren't special enough to break the rules. So every single method that you have on the search object in Elasticsearch DSL will return you a copy. The chaining works just as expected. And the other important part that people sometimes forget about when talking about consistency is the naming. Name things consistently. Name things consistently with other systems, but more exactly within your system. Always call it the same, and that is both in your code and also in your documentation. And of course, only do this if this makes sense. Because practicality always beats purity in Python. Like we are practical people. We're not really interested in the pure purity just for its sake. So don't be afraid to make an exception. Like, try not to make one, but if you have to, that's okay. So in our case, we have the queries on at the top that follow the pattern. Every call to a method will create a clone of the query object, mutate it, and return it. However, when I tried to do this for aggregations, this just didn't work because aggregations can be nested. And the first way how people, me including, try to represent nested aggregations would be just to nest the chaining calls. And at that point, it all broke down. I couldn't no longer be creating a copy after every call. So I had to break the pattern. So when you access as.ags, it's actually done in place. So don't be afraid to break the rules. Try not to, but also keep in mind that it might happen that you just will have to. And that's okay. The Zen of Python says so, and smarter people than me wrote that, so I'm okay with it. Another very important rule when designing an API is be friendly. Be friendly to your users on both sides. Be friendly to the users of your API, but also be friendly to the system that you're trying to simplify access to. And to me, the only non-obvious part, well, partly obvious because it's still pretty obvious, is to realize that Python is interactive. A lot of people use Python from stuff like IPython, or they use fancy IDEs to explore the APIs. And you should be able to support this. You should be able to help them with that by providing them all the tools that they could ever need. In the case of Python, those are the three main ones. Their representation and doc strings, which, if implemented properly, will greatly help with actually allowing the users to explore the API and start using it. Both the beginner users who just came to your code for the first time and are just exploring around, and also the advanced users, where this can greatly speed up the process. For example, the representation string is often underestimated, and it can be super useful. One of the most common questions that I get with Elasticsearch DSL is, I have this crazy query in JSON that somebody wrote or some other tool generated. How do I express this in Elasticsearch DSL? Well, I say that's easy. You just create a query out of it by wrapping it in the queue object, and just ask for the representation. And what you get back is exactly the code that it would take to reconstruct that just using the DSL library. So that's what really the representation string should be, a representation of the object that you can essentially retype into Python and get the same thing. In some cases, it's not practical if you have large objects, obviously, or you have something that can only exist once. It's not that useful. But in this case, it is definitely very useful, and it saves me a lot of time because this is something that I myself use quite often. That I have this crazy dictionary containing a crazy query with 10 different subqueries and 50 aggregations, and I want to manipulate it. And manipulating the dictionary itself is quite difficult. That's why I created this library in the first place. So I just wrap it in the queue object, get the query object that I can work with, and then when I want to put it in my code, I can use the representation and put it in there. And of course, doc strings. Be nice to your users. provide even some examples in your docstring. Those are the most useful. If you're reading a header of a method like this, it's pretty evident what it does. But if it were anything more involved with more parameters, it's always nice to include an example right there, both for when somebody is reading the code and also when somebody is just looking in their IPython on what's actually going on. So that's one part of Python being interactive. That's the more obvious part. The second part is enable iterative build, because again, the Zen of Python teaches us that flat is better than nested and sparse is better than dense. So what does that mean? If you build something up, if you want to build a sophisticated query into Elasticsearch, you keep adding clauses. First filter on this, then on that, add this aggregation, and if the user requested this filtering, add this kind of filter. So there is a complicated state that you need to remember what the query currently looks like. And it's a sign of a polite API, as I would call it, that it doesn't force you to remember the state, but it can store the state internally. So you can use the API from the get-go and start building your query in this case, or your request in other cases. And you don't have to store everything yourself. So in our case, it looks like this. You can also see that this enables for nice practices like commenting the code and actually explaining to the users what they're doing. And I can go line by line and very easily deconstruct it. Even if you're new to Elasticsearch, you would probably be more or less able to tell what this does, especially with the comments. So, sure, there's still some magic. There's still something that's specific to Elasticsearch. We've talked about the term and match and all the different weirdness of the syntax. But overall, this should not be surprising. I want to only filter category search, then I want to match the title to Python, etc., etc. But the most important part is I don't have to first build up some weird dictionary containing all the keyword arguments or represent the state in any way. I can just keep creating and keep adding to the search object and be happy with that. So iterative build, it's often something that's underappreciated because it allows you to not care about the state, which can be very hard. And finally, when we're talking about being friendly, safety is also very friendly. You should always fail explicitly unless it's explicitly silenced. So all your defaults should actually be the safest possible. So if you have any option to fail, for example, Elasticsearch will always give you a response even if only 20% of your data is available. It will give you a response and say, hey, I only see 20% of your data, but here, have some results anyway. And then it's up to the user to decide whether that's good for them or bad. When faced with a decision like this, like do I fail in this case, or is it okay and do I leave it to the user? I say always fail, but allow the user to override it. Allow the user to say, I'm aware that this is a situation that might happen, and I don't care. But at that point, you force the user to explicitly own the responsibility to maybe even do some research. You've noticed that that's something that I've repeated quite often during this talk, to not be afraid to force the user to actually learn something about what they're doing. And this one is particularly important because, hey, it deals with safety and it helps prevent nasty surprises once the user moves to production. Also, think about how you test your code and how other people test their code. Provide some sort of dummy interface, or maybe just a set of test case classes for your favorite testing libraries out there, so that people have lower barrier to entry to do some testing. Essentially, obey the testing code. Make the testing as simple as possible, because that's what you want to do. Ideally, you already have some code like that somewhere in there already, because you should be testing the API. So it's only a matter of exposing that part also to your users, sort of a test helpers or something like that. And the final chapter is about API still being code. It's different from an application code, and we've highlighted the reasons how, but it's also similar in a lot of cases. It needs to be tested. Things can change, and you might need to adapt. Also, there is a lot of decisions going into how do you decide what goes in and what doesn't. What are the features that you want as part of your library, as part of your API, and what do you leave sort of as an exercise to the user? Do I provide this set of helpers? Do I expose this functionality, this parameter, or is it only used by a very few people? And there are several ways how to do that. First of all is the actual decision, but second is, that's my favorite, to avoid that decision and allow the more advanced users to always step away a little bit and provide them access to the lower layer, the more low-level API. In case of Elasticsearch, I can always go one step back and just send in a raw dictionary. If I don't want to create the query using the iterative syntax that I just showed you, I can always just create it myself. And at that point, I don't have to care what options are supported by the DSL and which aren't. I can just do everything manually and send it back. The same, again, it's not a novel idea. It's the same with the .raw method on Django query sets, where you can just send in a SQL query when you don't want to rely on the ORM to generate one for you. So always allow access to the lower level if at all possible. And also admit that no code is perfect. And that goes especially for APIs, because they are vaguer than the actual application code. And when deciding what to include and what not, keep in mind the last line of Zen of Python that we'll deal with today is, now is better than never, although never is often better than right now. And that's an important thing. When you don't know whether to include something or not, it's perfectly fine to say no, especially if you have a way for the user to move around you. And so I always prefer to give them a way around my code than to try and support all the different possible avenues through my code, because that can lead to a nightmare. That can lead to a nightmare for my users with an overwhelming amount of options, and definitely in a nightmare for me, supporting all the different combinations. So think about what makes sense and how hard it is to do it without direct support in your code. If it means that when I'm not supporting this option, a user will have to create a dictionary and send it in manually, I'm okay with that. If it means that they will have to instantiate a new connection and talk to a socket directly and do some other complicated stuff, maybe not that much. And I want to provide them that functionality directly. So that's sort of the last part of how you decide what to support and what not to support. And now I believe we have 10 minutes for questions. If you don't get your questions answered or you just want to yell at me, there is my Twitter. And anybody has any questions? Thank you.
Thank you for your talk. And I had a question. So, if we create a great API with expressive syntax, don't you think that we're making the internals of the API more complex and really hard to maintain? Can we avoid that?
Yes, there is not necessarily a correlation between the complexity and the ease of use. Yes, sometimes you might need to resolve to more complex things like using meta classes and descriptors if you want to make things nice, but it's not necessarily true. So it might happen, but it doesn't have to. There is no direct correlation there.
Thanks.
Anyone else?
Two gentlemen.
Hi. What role do you think emulating built-in objects or using like Python types, like the built-in types, comes into writing a Pythonic API? For example, when should you think you should use dictionaries lots, or should you instead use make a little DSL for your particular thing? Or
I see. So I prefer to again decide what can you take away and then compare the results. So if I use raw dictionaries and if I create my own thing, what part of the pain goes away? Is it enough to justify the extra dependency, the work that will go into the API, etc.? Just sort of do this exercise in your mind, like, okay, these things I can abstract away, these things I can generate automatically, so the user will only have to put in these four things. And then compare the results. It might be that the differences wouldn't be big enough to justify creating a DSL, creating a library from both the point of putting the work in and also forcing the people to learn that. So that's what I do. Like every time, I sort of mock up how the API would look like, and then I compare. Is it worth it or is it not? Does it make sense?
Okay, I think we have time for one more question. Do we have anyone? Okay, if you have any more questions, you can just grab them at coffee or during lunch. Give them a big hand of applause.
Thank you.
I could start. I just want to make like a small announcement for people coming in. Like, hey, start your devices. Go to this website. Is this on button? Yeah. Okay. Okay. Just as a small hint, we are going to do a fun experiment in a bit. Preferably use your laptop for this. It will work on mobile, it's just your experience is going to be a little bit worse. I'm good, yep.
Okay, so our next speaker has a great title. I'm hoping for a great presentation as well. It's The Joy of Simulation for Fun and Profit by Vincent Warmerdam.
So hi everyone, thanks for having me over. Y buenos dias, me gusta estar en Bilbao. I'm going to talk to you guys today about the joy of simulation. My name is Vincent, I'm from Amsterdam, and what we're going to do in the beginning is I need you guys to get out your laptops and go to this one website. While you're doing that, what we're going to discuss today is what randomness is and what it isn't. Then I'm going to explain to you guys how sampling can actually be used to, do a bit of inference, which is nice. I will then demonstrate a couple of experiments that I've done with sampling. So I'm going to explain to you how I derived some better tactics for Monopoly using simulation. I will explain to you how I found out that you can sell Legos on Lego minifigures on eBay for a bit of profit. I'm going to then talk about how sampling can be used as an optimization tactic. And I'll conclude by talking about how we can outsource creativity a bit by using sampling. And then I'll talk about some Pokemon-related subject, which somehow blends everything together. So, randomness. Before talking about what randomness is, because we're going to be sampling, we should be sure that we understand what randomness isn't. Because, we're humans, and computers nowadays tend to be a little bit better at understanding randomness than we are. So if you could all please go to the website that I've just told you about, and we're going to go ahead and do a bit of an inverse Turing test. So this would be the website. This would be my blog. And then there's this one blog post called Human Entropy. Please go there right now. And you should see a website that's somewhat similar to this. And you could read it, but the idea is we're going to go ahead and try to generate random numbers. So put your index finger on the 1, put your other index finger on the 0, or use these two buttons. You will notice that if you click, the number will increase. And let's just go ahead and do this. Just generate a bunch of random numbers and try to generate them as randomly as you can, but let's generate about 100 of them. I'm going to go ahead and generate just a few more, and I'll give you guys a couple more seconds so you can do the experiment yourself. So I've almost got about 200 numbers, and you can see the JavaScript slowing down. Hopefully it's not too bad for the Wi-Fi. So I've just generated a bunch of numbers. I, as a human, said, okay, let's 001, 110, 001, 110, and let's see what I've then done. If I scroll down, what I will then see is I will see all these histograms of how often I picked a 1 and how often I picked a 0. But also how often I picked a 0 after a 0 and a 0 after a 1, etc., etc., etc. And what you notice is even though I'm trying to be kind of random, I'm trying to make as many 1s as I am trying to make as many 0s, you will notice that I usually fall into this pattern where I do a 1 after a 0 and a 0 after a 1. And this is very normal as a human being because it feels random even though it totally isn't. And this small web app, you can read up the math if you want. It tries to do a real-time prediction of what you're going to type in next. And you can also track how good the accuracy is. So if I just reload the page, this will be more of a real-time thing. So 001, 110, 001, 110. Not random at all. And then at the bottom you can see that the probability of me being a human me being a robot is quite low. So, I like this idea of human inference because in a way this is an inverse Turing test. By checking if you can actually generate random numbers, I am actually able to say that you are definitely not a computer. Anyway, so this is a sort of way I hopefully real quickly explain to you guys how randomness works and how it doesn't work. It is useful to have some form of randomness available to you, but you as a human simply are not good at generating it. Therefore, we're going to use a computer instead. Another sort of cool thing, if you're interested in playing with it. I'm just going to do 0, 0, 1, just repeatedly one after the other. And you see that there's this estimator that tries to predict what I'm going to generate next. And you'll see that at some point the probability of me getting predicting a 1 is, first it's a 1, then it's a 0, and probability switch. But if I now switch my algorithm, so I'm only going to generate zeros now, you will notice that there's a bit of confusion, but after a while it has picked up my new pattern and the accuracy goes up again. And if I do only 1s now, you'll see the same pattern as well. The cool thing about this is, because I have these laws of probability to my disposal, I can use a little bit of math to do all of these predictions, but it's still useful to have random samples. So, after this small demonstration, hopefully it's obvious that human entropy generally is quite terrible. This is why we prefer to use a computer to help us think about probability, and because we have this computer available to us, and because we can sample quite fast, we can kind of avoid doing a little bit of math. Because, math is hard, and even though it is very useful, we do like to just get the job done. So the goal of this talk is to convince you that you can do a lot of these tasks just by getting samples instead. And I guess the easiest way to explain, sort of from a modeling perspective, why samples are useful, sometimes we know the characteristics of a system, but we like to know the likelihood of a certain event happening. And again, it might be easier to use sampling instead of maps to do the inference for us. And the simplest example I could come up with was, suppose you have a lot of dice, you roll the dice, and then there's a probability that a certain number of eyes pop out. And I could calculate that. I mean, there's laws of probability. Instead, what I could also just go ahead and do is I can draw histograms. This is the histogram for if I have 1 die. This is the histogram for if I have 2 dice. This is for if I have 3 dice, etc. And I also get this nice probability distribution out that I didn't have to do any math for. I could just sample it. And the nice thing about this is I can ask this thing 2 questions. Suppose that I roll 4 dice. What is the probability of getting a certain number of eyes? This is sort of the sum. But I can also ask it a different question. I can also ask, hey, given this number of eyes, how likely is it that I have been rolling 8 dice? I know the rules of the system, I can describe them, and from there on I can sample it. And that means that I don't have to do math, but I can still do inference on these things. So it's sort of, can I look at it from this direction, but I can also look at it from this direction. This is a powerful thing, and this is something that Bayesians tend to like a lot. If you're interested in this kind of sampling, by the way, please consider looking at this library called PyMC3, or this other library called EMC. These sampling methods for inference are very powerful. It's a little bit too theoretical for this talk, but if you're interested, there's a very nice tutorial on my blog which explains how you can do some sort of time series analysis with these sampling tactics as well. Because here I'm just doing inference on dice, but you can do inference on time series as well. But anyway, let's consider a fun example of how I actually got better at doing something because I had this computer available and I could do a bit of sampling. Do we know this game? Yes? Do we also always play this game during Christmas where you guys are from? My dad always makes me play this game during Christmas, and I absolutely despise the game. I don't see any joy in it whatsoever. So I figured, how about it might be fun. If I don't enjoy playing the game, I could at least enjoy beating my dad at it. So the idea would be, can I use sampling a little bit to get better at this game? Because if I think about it, every tile on this board is worth something, and I can calculate the expected value if only I knew what the probability was that it would actually land on such a tile. Okay, so math-wise this would be a little bit hard because you have to do a lot of formulas. What I can also just do is I can say, okay, let's just for 10,000 times, I know the rules of the system, I know the rules of the game, I can get that from the web. Let's just have everyone start here and just start rolling dice and use the rules of the game, just check what the long-term probability is that you'll land on a certain tile. There's a very interesting characteristic of this game because the likelihood of being around this corner of the board is quite high because you have this go-to-jail mechanic. So I did this in a simple way. I didn't include any of the cards, but I did end up with a histogram that looks like this. So at the x-axis, you'll see the sort of the number of the tiles. This would be tile number 0. This would be tile number 39. And here you can see the likelihood of you landing somewhere. And you'll notice this obvious spike, which coincides to be jail. Be here, by the way. But the most interesting thing that you'll notice is after jail, there seems to be a slightly higher likelihood to be at 2 steps away from jail, 4 steps away from jail, 6, 8, 10, and 12 steps away from jail. And the reason for that is because it's so likely that you get into jail, if you want to get out of jail, you have to roll the same dice twice, which is why it's more likely that you'll land in one of these areas. And if you know that beforehand, you can change your tactic a little bit. For example, and I know there's a lot of randomness in the game, but if I were to choose a station on this board, it seems more relevant that I would take this station and that station if I were given the choice. And now I can calculate how much likelier it is that you actually land there. Reading would be the first station, this would be the second one, this would be the third one, this would be the fourth one. And you can see that it's not, twice as likely, but there's a bit of bias there, which you can potentially use. And again, this is something I did for the stations. Each station generates the same amount of revenue, but you can scrape Monopoly.com or something like that, and you can actually get the amount of money out that you can get if you land on one of these places. And this is a nice table, which is sort of cool, but then the obvious thing to do is just go ahead and plot this. So for every tile that you can buy, you'll see a point listed here. This is the probability that you will land on said tile, and this is the rent that you can charge if someone lands on the tile itself. The size of the point would be the expected value. So if the point is very big, that means on average, after every game, the tile will generate more revenue from you. And the thing that you immediately notice is, there seems to be sort of an efficient ISO curve. Like everything on this imaginary line seems to be worthwhile, while down here at the bottom, there's a couple of, not really performing at all spots that you can buy. Can anyone guess which spots those are? It's probably not these. It's probably not these. It would be these, yes. And the two big dots that you saw, those would be these two. The odds of you landing there are quite small, but if you actually land there, boy, are you in trouble. It's sort of the risk bias kind of thing. It's very risky, but there's a lower probability of landing here simply because of the go to jail thing that happened before. And, I'm not drawing it with the points, but you see this pattern also if you've bought a house there, and if you bought a second house there, etc., etc., etc. So, I'm not saying that I actually got much better at playing this game, but I did understand the game a whole lot better, and it didn't really measure how often I won. But I like the fact that just by using a little bit of sampling, I actually understand the game a whole lot better. I know the mechanics of the system, but then I can, collect data by sampling, and then suddenly I understand the game a whole lot better. Turns out this is also on the blog if you're interested, and this blog post is trending on Hacker News for a while, and the kind people on the internet then point out to all the weaknesses of the blog post. There was one guy, this is sort of the flaw if you're modeling always. I think this is an okay model to start with, but obviously it doesn't encompass everything in the game. So there was one person in particular who was very adamant and said, look, if you want to win, you should buy these places. These are the ones you want to have. And the reason is there's this mechanic in the game that if you buy all the houses first, no one else can buy houses. So if you are the person who actually owns all the houses here, no one can invest in houses on any of these lots, and then suddenly these do become more valuable. And again, we could go a little bit further, and we could go and go in depth on how that would work. And a colleague of mine actually built a bit of software around this that you can send your own genetic bots to play this game with a certain strategy. Talk to me after this talk if you're interested. So this was definitely a thing that I thought was fun. I understood the game better. It turned out to be a nice blog post, and it was a nice example of when sampling does something nice. But there's also, it's a little bit of a crazy example, but there's also some places where in practice I want to make a living, and I might actually make a little bit more money if I just do the inference via sampling. And the best example of that I have are these Lego minifigures. Are we familiar with Lego minifigures? Just a show of hands. Does everyone know what I'm talking about? Okay, everyone knows what I'm talking about. Great. So Legos is a smart company. Legos at some point realized, like, hey, if we combine Star Wars and Legos, then we've got two collector's items in one, and there will be more people who will be willing to buy that. So collector's items, you can make a lot of money of it. This is the original Lego minifigure series, and Lego minifigures are kind of like the Kinder Bueno. You open up the packet, but you don't know which Lego minifigure is in there, but there are 16 in the set, and after 2 months or so, they're never going to produce a set again. So I figured, okay, that sounds interesting. Would there be a market for this? So you go to this second-hand website, and you scrape a little bit of data, and you make a small little histogram, because you want to try to see if you supposedly invest in Lego minifigures at the moment, if it will be profitable to sell them later. This is the histogram you would get out, which isn't that pretty, because I don't really have an impression of what the average price might be. There seem to be a lot around here, but there's a thick tail over there as well. So how do I get a good impression of what the average might be? Okay, so I'll do a bit of bootstrapping. I say that I have 60 of these prices. I'm just going to grab 30 at random and calculate the average. I'm going to repeat that over and over. And that way I get a more smooth curve so I can visually interpret the plot a little bit better. And turns out this is for the Simpsons Lego minifigures that I was looking at. These are for the other ones. At the time, the Simpsons Lego minifigure one was the most recent one. And I can imagine that as the series gets older, it'll be worth more. So, okay, this might be a good average to look at. And you shouldn't always look at averages, but this seems reliable enough. So these were the figures that I had. I can buy a Lego minifigure for €3 a piece, and I can sell a full set for €100 later. How likely is it to get the full set? And I was a little bit ignorant. I figured I'd do this with math. And when I say I'm going to do this with math, I'm going to do this in a programmer's way in math. So you go to Math Overflow, and you present the question, and then you get this answer back, which is even more complicated. Turns out there's this thing called Stirling set numbers, which is, I'm sure it's interesting theory, but I want to solve the problem. So instead of looking at math or even Stack Overflow that comes to the rescue, I should probably just, simulate this. So I did. Here you see the number of packets that I would buy, and the line itself shows the probability of getting a full set, but the dotted line shows the expected number of total sets that I would have had. Because obviously if I buy 100 packets, the odds of getting at least one full set is quite great, but I might actually have 2 sets. That's sort of rather likely. And again, whenever you're doing these sorts of things, it's always nice to visualize once in a while, because if you visualize something, then you can get surprised. Because when I was looking at this, it sort of made me wonder, gee, if I have one set, and I start collecting even more, from the first set that I collected, I probably have some spare Lego minifigures, which I can probably use to make sure that the second set that I buy is actually easier to collect. So I figured out I'd plot that. I simulated this over and over and over again, and the blue line that you see here, this is again the number of packets. This would be the number of sets that I would have had. This shows the average amount of time that you might need to get one full set. Like, theoretically, you need about 50. That seems all right. But the time it takes here is much more than the time it takes here, which in turn is more than the time it takes here, which in turn is more than the time it takes here. So the more Legos I buy, the higher the likelihood is that I'll have more sets. And again, this seems intuitive, but it's because I've done the inference that I was able to figure this out. So again, sampling is very useful. In Amsterdam, I often give this course in probability theory, so this seemed like a nice example. I ended up giving this course to a bunch of bankers, and in the latter part of the afternoon, we happily opened one of these boxes to see if the inference was correct. Turns out if you open one of these boxes up, you will always have 3 sets. It's not even randomly distributed, but it's still a fun thought exercise. So these are sort of the obvious use cases when you think of simulation, right? You use simulation because you don't want to do the probability theory. But there's actually other fields than just probability theory that can, get a nice benefit from doing a good simulation exercise. So let's talk about more general use cases, and let's talk about optimization in general. And to give the idea of how it works, I'm going to give a slightly silly example. So this is an example where we know the correct answer beforehand, but suppose we have a 1x1 square, and we want to find the largest triangle in this 1x1 square. And again, this is a very silly example. We know what the largest triangle is. You just, make the diagonal and you're done. But let's say that this is a system that we want to optimize, and the computer has no notion of what the best parameters are. We're interested in finding 3 points, and the area in between these 3 points has to be the biggest. That's the only thing that's known to the computer, and the computer doesn't know any math further than that. So what's the first thing that you could do? Well, how about we just, generate a whole bunch of random triangles and pick the best one. See how good that works. So that's what I'm doing here. Is sort of the code that you would sort of need. You just generate a whole bunch of random values in 6 dimensions. So you have x1, x2, x3, y1, y2, y3. Those are the 3 points. And then there's this function called the shoelace function, which then calculates what's the area between all these points. And you do that for a whole bunch, and you can draw the result. And, the largest triangle will be 0.5, and the probability of actually sampling a triangle from this region is rather low, and this doesn't surprise me. So what could we possibly do? Well, what I could do is I could say, gee, I have an area and I have all of these x coordinates. How about I throw away all the bad triangles that I have? Because I can take the average of all the triangle sizes and I can just throw away the half that's at the bottom. I can keep the ones that are on top. And instead of looking at the area, how about I look at the distribution of the points? there's a distribution there. And as luck would have it, if you have a sample size that's rather big, what you could do is you could give that to scikit-learn, because scikit-learn has a nice density estimator. So that's what you see visualized here. This is the density plot for the points that are performing well. And to just sort of zoom in a bit, this is x1, x2, and x3, and it seems that if I want to get a good triangle, then either x1 it has to be a low number or a high number, and if x1 is a low number, then x2 has to be a low number as well, or a high number. This coincides with my belief of what a big triangle should be, so that's sort of nice. Not only, if I do this, not only can I maybe get a sampling technique that gives me better triangles, but I can understand the problem a bit better as well, just like with Monopoly and just like with the Lego example that I had. And this is what the x and y distributions look like. Again, on this bigger plot, this is just the x's or the y's. These are the x's and the y's together. And what I see sort of makes sense. I like it if my x is small, then my y might be big. That makes complete sense to do like that. All right, so I have this distribution. Let's sample from this one. So the idea is I've selected areas that are big. I'm going to sample from that distribution instead. This is what I had before, and if I do a new sample that I've just learned, I will sample from this distribution instead. And again, what you will notice, it's a lot likelier that I'm going to sample larger triangles. So how about I just repeat this? Sample over, sample over, sample over, sample over. And the nice thing is we can repeat the same idea until some sort of convergence pops out. Note that mathematically I've said, hey, we're going to select the areas that are larger than some m. You could take m to be the average. You could pick whatever other metric. But the cool bonus is that if you do an algorithm like this, then we can use inference on our simulated data to learn more about the nature of optimization problem. And if you're familiar with genetic algorithms, you may notice that they actually work in a quite similar fashion. Except here I'm trying to look at the distribution of the parameters, whereas a genetic algorithm would use a similar tactic to just do a proper search through the entire grid. Should you be interested in learning more about this, there is this colleague of mine, he's sitting there, and he'll talk about this sort of thing more in detail later this week. Specifically, he'll talk about how you can win the board game Risk, or how to conquer the world, as the title would say. It's Thursday, 12 o'clock in a PyCharm room, and he'll talk more about genetic algorithms in general and how you can apply this to many, many things. Because what you'll probably have noticed as well, this is triangles, but I can sample anything. If it's continuous or discrete, it's just a sampling exercise, which means that I have a very flexible way of optimizing any system. That's not to say that I always find the best solution, but this is a proper way to do a form of search. Hopefully by now, I have convinced you that sampling is indeed useful, and it can be a little bit surprising in its use cases. What I'm going to talk about now is sort of my hobby project for the next year, I think, and it's the thing I'm most interested in at the moment, and those are generative methods. And the thing that I like about them is they sort of allow you to outsource creativity, and entropy has a small role to play in this. So far the distributions have been a little bit static, and in this next bit I'll introduce a little bit more Markovian way to think about randomness. Because so far I've said, here's a distribution, give me a sample, give me a sample. And it wasn't really the case that the sample that I just got determines in a little bit the next sample. This is literally what is listed on my LinkedIn profile. And if you would please spend a little bit of time actually reading it. Some of you may understand the joke. It seems surprisingly relevant nowadays. A few people giggle. I'm hoping for a little bit more people to giggle. Yes, a couple of people are understanding the joke. So, if you're on LinkedIn, you want to write down what sort of stuff you do. So you write down R, Python, JavaScript, and sort of the keyword bingo that everyone plays. Which is, nice, but you get all these nasty recruiters on your profile, which you tend to not like. So I figured it'd be fun to just add a couple of Pokemon in there as well. So there's Ditto, Lodash. No, Lodash is actually a thing. Vulpix, Git. So again, the main reason is I like to confuse recruiters a bit. I'm a little bit mean. I probably shouldn't be, but there's nothing more fun than if a recruiter says, hey, would you come to work for my corporate bank? And that you can then say, well, do you guys use Spark, Hadoop, and Metapod? And the recruiter says, yes, obviously, we use all the latest technologies. The recruiter in question wouldn't be entirely wrong, right? I mean, recruiters are terrible classifiers for Pokemon. Recruiters cannot really distinguish a Pokemon name versus the name of a technology. So I figured making a Python library that can generate Pokemon names might actually be fun. So the library is called Grabble. It's totally not done yet, but the idea is to have tech names for a service. And before you start thinking, gee, that's ridiculous, Vincent, speaking of Pokemon as tech names, there's this GitHub repo. Turns out that a lot of people have used Pokemon names for their original GitHub projects. There's a link in the presentations if you want to look at it later, it'd be fine. But Metapod is actually it's not necessarily a big data technology, but it's a template-based robot dynamics library. And there's this lovely little web page that for every 750-ish Pokemon gives you a link to GitHub with a name of a Pokemon in the package. Anyway, back to serious stuff. The reason why I want to make Grabble is I've always been a user of libraries, but I've never really written one myself, and the problem seemed interesting enough. I will most likely learn from doing this, so I'll probably write like a Twitter bot someday that's sort of called Tenas, Tech Names as a Service or something. So the idea is to generate names that sound like Pokemon. And to put it bluntly, the whole point of Grabble is to come up with a better name. And then I started thinking about it. Okay, so I want to generate Pokemon names. That seems like an interesting problem. But it involves generating a believable sequence of tokens. And when you think about it, I could do this for Pokemon names, but there are many other things I could do as well, like Red Hot Chili Pepper lyrics, or IKEA furniture names, or notes on a piano. So the simplest model that you could possibly then think of is say, okay, suppose I have some token. This is independent of if it's a letter in a word, or if it's a word in a sentence, or if it's a MIDI note in an entire arrangement, or if it's, sound in a IKEA furniture. But the idea is once I know the previous token, I might have some other probability distribution for the next token. That's sort of what Markovian thinking is all about. Depending on the state that I am in now, I will sample from a different distribution for my next token. And this is the simplest model. If I see the letter A beforehand, probably the chance of seeing another vowel should be somewhat smaller, and seeing a consonant might be somewhat larger. But you can also do it not just for the last token, but the token before that as well. This is sort of generating a Markov chain that you're going to learn, and then you're going to try and walk it. And sort of the basic way of doing it is to say, okay, I have this Markov chain. I can look forward. Maybe I look back a bit as well. So if I'm generating the third token, I should look at the second token and the first one. So it's a Markov chain of rank 2 in this sense. But if you really wanted to, this is just a way of thinking about it. If I know T1, then the distribution for T2 is set. It's sort of the sampling rule, if you will. But who says it has to be ordered in one direction? I can also model this in a way that you can model it from two directions. Because if you think about it, it seems fine to start with the first letter of the Pokemon name, because there's a prior belief that you could start with a certain letter. But there's probably a different distribution for the last letter as well. So it doesn't seem entirely unsensible that Pokemon probably don't end with the letter I, for example. So maybe we shouldn't have a Markov chain that goes one way, but a Markov chain that goes both ways in. It seems rather sensible, and it's sort of the same probabilistic model. So I'm playing around with this, so I'd just like to give you a preview. Here are some Pokemon names I came up with. Lido, Keen, Cool, Rhesus, Poulet, Utkata, U-Tail, especially like U-Tail for some reason. Olma, Elitip. So these seem rather plausible. The Red Hot Chili Pepper results are just hilarious. Can you believe, hold me please, by the way, I wonder what the wave meant. White heat is screaming in the nearest bin. When I was fortunate, I know you must have been fat this year. Eat the sun at a bottom dollar, foxhole love pie in your house, then let me spin feather light, but you can't move this. And the sort of the lovely joy of doing things, like making these sorts of models, isn't that this is accurate, but it is somehow accurate. Like I somehow do believe that this came from Red Hot Chili Peppers, and let's say not Blink-182 or something like that. What you also sort of notice is that the corpus of the Red Hot Chili Pepper lyrics is somewhat limited. So if I say, by the way, which is obviously always going to be together, what the wave meant I think was also like literally in one of their songs. So the corpus does have some influence, but this sort of works, and that's exciting. Same thing for IKEA furniture. I don't know about you guys, but I would definitely like to have a Ripe couch or a Europs thing. Yeah, so the problem... Okay, so the reason why this happened was I was talking to my girlfriend about this problem over dinner, and she was obviously not super impressed. Really, Vincent, you're spending your time on this? Instead of making Pokemon names, how about you make IKEA furniture names? I was like, that's an excellent idea. Anyway, the thing is, I've just shown you the nice bits. A lot of these are actually quite wrong. I mean, these were a lot of samples that didn't really make the cut. So I really think A is a terrible name for furniture or a Pokemon. Day also seems a bit odd. And yeah, which I think is also still a hilarious one. So there's still work to be done. And just sort of to explain how I'm thinking about maybe tackling the problem and some stuff I learned from just thinking about this. In the machine learning community, it's very normal to make ensembles of models. Instead of just making one model, how about you make 10 of them and combine them in some way? Because it seems sensible that if this model works somehow, but this one works also but in a slightly different way, you should be able to combine them. And the laws of probability certainly allow for this. So that seems like a thing I could do to make this better. Another thing that I could do is, my library has this notion of a lexicon, which is sort of like a data frame, and a model would be like a model, but instead of having a data frame, you need some sort of bag for sequences of tokens. What I could also do is say, hey, here I've got this lexicon with all the Pokemon names, train it. Here I've got this lexicon of the English language, because maybe I want to have Pokemon that actually sound English. And then I could go ahead and combine the two. And then these would be two models that aren't just two different models, but they're also trained on different data, but they can actually, be glued together to maybe get better sequences. It's a very fun experiment in my mind to generate Pokemon names that sound French or Pokemon names that sound German. What I could also do is maybe do something with transcriber or some form of transducer. In the Pokemon names, it seems very obvious that instead of just focusing on this letter came after that letter, I might actually give some domain knowledge and say, this letter happens to be a consonant, and the odds of getting 3 consonants after each other is rather low. So then I would translate, sort of as a mapping, the lexicon to something else and train another model that coincides. This seems like a viable tactic because you can sort of do extra domain knowledge in your model this way. What you can also do is you can try to add judges. How about I generate 100 samples on this one that was based on this one model, and have this other model that would judge this model. So from the 100 samples, I will sort them all and maybe take the top 10. This also seems like an appropriate way of thinking about it. I can also think more, this would be sort of hardcore, but you can also think about it not in a Markovian way, but maybe just generate a factor graph instead. This has some nice benefits. And maybe we can even take this Levenstein-ish approach, where I start out with a Pokemon name, and one by one, randomly, I change a letter. Also a way to generate something that should be sounding plausible. And the nice thing about doing it this way is I'm not necessarily limited to just probability theory, but I can use Jensen's word-to-vec algorithm here. And then you can sort of wonder, hey, what a word is in a sentence, there's some context there, but what would a letter in this, like a token in a sequence be? It's also sort of an interesting way. Like we could have like token to vec. We can also consider these deep models, which is fashionable nowadays. And the way that would work is you would say, I have a start token, and I have some prior beliefs, so generate that. I'm going to sample all the way down until I see some sort of stop token. This is nice, but it has some sort of, I have some features that I would like to have, which this way of thinking doesn't necessarily support. Suppose I want to generate a Pokemon name with 6 letters, and I know the second one and the 6th one. How am I going to generate the others? This is what makes the problem hard, so I'm not sure if I want to give support to this, but if you are a deep learning specialist, or think you are, and you know the solution to this, please come talk to me. I'd love to hear what you think about it. So I will focus on the following domains. Probabilistic graphical models seem all right, heuristic approaches seem all right, and deep learning seems all right. It's very interesting to see how the fields are converging, because nowadays you can use a neural net as a generative algorithm, which takes some sort of Gaussian in and generates some sort of generated distribution out. This is from the OpenAI page. It's got some lovely research on projects like this. And the rough API plan, which is sort of the main lesson that I had as I was designing this, instead of just writing code in a notebook, it seems like a better idea that before you write any actual code, you should wonder, what does the UI look like? I'm going to be the user. I'm going to be using this a lot. I have different lexicons. I have different models I'd love to train. What's the best way for me as a user to play around with this? So what you then do is just copy scikit-learn. There's some notion of a data frame, and I just call it a lexicon. There are these different models. So let's say I have a factor graph, a 2A Markov chain, etc. This is what defines the properties of the models, and I can later fit that on a separate lexicon. Once those models are trained, I can generate from them. And the hopeful idea is that I can somehow make an ensemble based on 2 different models, maybe even give them some weighting, and then sort the outcome of this by some sort of judging characteristic of a model. Simply by writing this down for myself, it's not even working yet, this made it a lot clearer for me to know what I should be building and how I should be designing things. And then hopefully, maybe by the end of next year, I can come back and talk about a model that can make Pokemon names where you say, hey, I don't know this token, I don't know that one, and I don't know that one, but I want the token to end with base. Especially in the market for making tech names, it seems very, very useful. You can do stuff like this. Another thing that's interesting, so this is sort of the deep neural dream of building something that works for tokens, but it works for art as well. This is actually something that doesn't use any entropy, but this is something that you can generate fairly easily in just a couple of lines in JavaScript. And if you're interested, if you're going to come on Friday to my Blender talk, we'll make pretty images sort of like this, but in 3D. That will be the goal of that talk. We'll just use simple cubes, and if you're interested, come talk to me. We're going to build pretty stuff that looks like this. So, concluding, sampling can be a whole lot of fun and sometimes actually profitable. Lego example. Getting started is super easy, and you might actually be surprised on how often it can help you out. Again, people don't necessarily always understand PyMC3 because it's a little bit less straightforward on the theory side, but you're very, very flexible. You can just describe a system and sample away, and you can actually solve a whole lot of problems. Python is a great use case language for this. It's actually surprisingly easy to be very flexible with just a couple of lines of code, and it's actually quite fast as well. I mean, NumPy is great. And if you're ever considering thinking about an API, this is something I kind of learned from the art community. Try to optimize for joy. You're going to be using the library maybe, and then it might be better to spend an entire day thinking about what the API would be like, such that it would be the most fun to start using the library. Instead of having a mountain you should climb in order to become a pro in the language, maybe we should have this pit that you just fall into and you're immediately a pro. Thanks for listening.
Okay.
I'd be happy to take any questions, but anything Pokemon related that's not about the game, you can also just talk to me in private when I'm outside somewhere.
Any questions?
No question. There's one person in the back there, I think, with the white shirt, I believe. I'm not wearing my glasses. Also, if you've done something similar to this, also come talk to me. This is sort of a hobby project, but I'd be happy to hear if someone else had done something similar.
Hey. My question is...
Can you speak up a little bit?
Yes, my question is, I'm not sure if it's an appropriate question, but if you had to simulate a network of queues, so you have a queue and a queue, how would you do that?
So that there's two queues next to each other.
Let's say there's a network, then maybe there's like three
so
of them.
So in the use case for MIDI, this is definitely a problem, right? Because if you're doing a MIDI track so Pokemon names, and this is a toy example, those are easy. The main gist of what I'm trying to get to at some point is this would be interesting for music, but music will be more difficult because then, let's say you have the bass that's playing, you have the drums that's playing, and then you have the melody, for example. Then you have three sequences that actually have to correlate somehow, but in this case don't really fit into this model. What you could do then is, that there's a couple of libraries that have a bit of support for this, but you kind of have to go into probabilistic graphical modeling in that way. The trick is to then say, there's two tricks you could do. There's one trick where you can say, these are three tokens that I can see as one separate token, and that will go into this one list, and I will try to generate that. This can be, you might need a lot of data before you actually get the pattern right, so that's a little bit expensive in a way. The other way is to not have the complexity in the data, but add complexity to the model, where you just say, hey, these are three time series, and they're somehow correlated, learn that. And you could do that with a sampling approach. PyMC3 has some examples of that, but then you get into sort of correlated time series land. If I have like a whiteboard, I can more easily explain that to you, so come to me afterwards if that's something you're interested in. But it is sort of doable. It's just hard.
Anyone else?
One person here. Yes? Mm-hmm. Okay, that's a good question. So, correct me if I'm wrong, but I believe the question is, hey, this is a nice talk, but obviously when you have more dimensions, this would be harder, right? So for the triangle example, that's reasonably easy because there's only 6 dimensions. And you'd be right. So the dimensionality is always an issue, right? And I believe, I'll just grab the picture. So suppose we had this, but in 12,000 dimensions. Obviously, it's a whole lot harder. What I would be more saying here is consider this as a approach. It actually has a couple of useful use cases, and you can actually solve some things with it. But especially in the optimization field where you have like lots of hills and many, many dimensions, the reason why we use genetic algorithms is that's because it's the best thing we have, not necessarily because that's the best thing we could have. When you go into random algorithms land, you do that because there's no alternative. There's greedy methods, but those have downsides too. Yep.
So I didn't quite get why couldn't you do like an LSTM?
So the thing with the LSTM is usually you can say, hey, generate lots and lots of sequences. The issue I sort of have is with this one use case. So suppose that you say, I want to have a Pokemon that starts with an H, then an A, and then after 3 tokens comes a P.
All right, so you want like...
Yes. I wanted to finish sequences.
But can't you like just plug in a bunch of Pokemon names and just sort of see what comes out?
One more time?
Like, can't you just plug in a bunch of Pokemon names and then see what comes out at the other end?
And I have, but then the thing is, suppose I stream all the Pokemon names in, right? So Pokemon name, it's learning, the internal state is there. Then usually how you would generate a new sequence would be to say, here's a start token, go. And then at some point it's going to sample an end token, and then it's done, then it has a Pokemon name. And what I could do is I could say, generate a whole lot of them, until at some point you have a Pokemon name that starts with an H, then an A, then 3 tokens, whatever, and then a P. But that feels like oversampling a bit.
For sure, yeah.
So this is more of an open problem. It's very fun to go to academic conferences and ask this to professors. But yeah, there should be a sort of more genetic, sort of more neural way to also approach this problem, and that's why the generative thing from OpenAI, where you actually add the entropy yourself, seems like a worthwhile venture. It's just that I've never really heard anyone say, "Here's an obvious solution to this problem," and like, it's not the most important problem in the world either, right? So I'm not, too angry about that.
Sure. Thank you.
Okay, let's give a big round of applause for Vincent Warmerdam.
Thanks.
the last talk of this session. First of all, I have two announcements. The first is it's the last talk before lunch, but lunch will have terrible queues anyway, so don't storm out if you think it's almost lunch. Also, secondly, don't storm out for lunch because we also have the massages Harry Percival was talking about yesterday in the lightning talks. So you can get either a massage or you can learn how to massage. It's outside the Pie Charm room or A3. And this is happening early in lunch. So while other people are queuing for their food, you can get a massage, so that sounds a lot better. So our next speaker, give a big round of applause for Dougal Matthews and Effective Code Review.
Thank you. Okay, so I've been, well, first of all, thanks all for coming and for having me here. I've been thinking about code review for quite some time now, so I'm quite excited to sort of talk about it and yeah, just sort of start a discussion about it. That's kind of my main goal from today is if people are talking about code review more, then I've had some success. So first of all, just to give you some context of where I come from, I mean, what I do isn't actually too important for this talk, but it's useful to know where I'm approaching code review from. I work for Red Hat, and then I'm working on the OpenStack project, which is the bottom logo. And then I work on OOO inside OpenStack. And the key thing about all of these is everything I do is open source and public, so all the code reviews I do are also public and open. So this means that some of the things I'm going to say are specific to open source, I guess, and maybe don't apply to a closed environment, but I think still a lot of the things do apply. And I also run the Python Glasgow user group in Scotland, which is completely unrelated, but I just like to show off our cool logo whenever I can. That's an inside joke which I can explain to anyone later if they don't understand it. I'm also doing a bit of an experiment in this talk. I've scheduled some tweets, and that's my Twitter account. The O in Dougal is a 0. It'll be tweeting out some relevant links to the talk. If there isn't 2 out by now, then it's not working. So yeah, we'll see afterwards. But if you're looking for references to any of the sort of the papers or blog posts that I reference, they should be shared on my Twitter. First of all, I'd just like to try and gauge the audience a little bit and see where people are at with code review, what you're doing. And to get a baseline, how many of you will raise your hand if I ask you to raise your hand? Okay, that's pretty good. That's, I guess we're talking about 90%, so anything can be adjusted to that from now on. And who's doing regular code reviews at work? And by this I mean as either the author or the reviewer of a change. Okay, that's a good percentage. We're looking at about 75% there maybe. And who is doing them outside of work, so maybe open source or in like a side project, something like that, again as author or reviewer. Okay, so that's a lot less than we're looking at about maybe 15–20%. Finally, who actually does code review but looks forward to doing it? Okay, so we pretty much had everyone doing some kind of code review, but then the number of people actually, so this is for the benefit of the video, I guess, if nothing else, the people actually looking forward to doing code review is probably down to about 20%. And this is the one that is the most interesting to me. I find code review incredibly valuable. There's so much you can get out of it. It's a really useful process, but yet a lot of people don't really enjoy it. So I'd like to start the discussion and see how we can improve that, how we can make it a better experience for everyone. I also done a straw poll on Twitter not too long ago, and I found out that most people are doing code review, sorry, out of all the people that responded, everyone's doing code review up to 25% or up to 50% of their day. Well, I think that's part of their development time. But that, I mean, that's a huge chunk of time. So if we can improve code review, we can improve what we build, or perhaps more importantly, we can actually improve how people enjoy their jobs. For anyone that's not doing code review, this talk is really more aimed towards people that are, but I just got to quickly do a couple of quotes, things which, if you need to persuade someone why you should be doing code review, will hopefully be useful, and there'll be some references to papers and blogs. So there's just 3 very quick slides. But as far as I'm concerned, the only real reason to not be doing code review is if you're a sole developer on a project. And you'll actually find that, oh sorry, there's a trick that I've used before. If you're doing an open source project, say on GitHub, rather than committing directly to master, if you open a pull request, you might find occasionally some people wander by and do a review before you merge your code, especially if you've got watchers on your project, because they get notifications when you do a pull request on your own repository. So first, this is a quote from a book called Code Complete by Steve McConnell. And he says that the average detection rate for unit tests is 25%, 35% for function tests, 45% for integration tests, and in contrast, the average effectiveness of design and code inspections is 55 and 60%. So in this, when he's talking about defects, it's kind of bugs or problems with the code. And he's basically claiming that code review is the most effective out of all these approaches to improve your software. I'm not sure I completely buy these numbers, but even if it was on par with your testing, that's quite an impressive amount of benefit that you can get. Next, there's a quote by Jeff Atwood. So he wrote this in a blog post, and basically said the only hurdle to doing code review is finding a developer that you trust to actually do the code review. And then once you've started, he says, I think you'll quickly find that every minute you spend in a code review is paid back tenfold. And this one really tackles the assumption a lot of people say they just don't have time to do code review. But really, I think there'll be some upfront investment, of course, but once you actually start getting into the process of it, you will find that you will reap the benefits over time. And then finally, from a paper measuring defect potentials and defect removal efficiency, academic names are great, they found that formal design and code inspections often top 85% defect removal and average at around 65%. So again, this is like a huge number, and this is quite good because this is from an academic paper, and they share some of the data they use, so there's actually quite a lot of method behind these numbers. The other two were more anecdotal as far as I could tell. So with that aside, hopefully you're all convinced now to do code review, or as most of you are doing it anyway, we can move on. But if anyone is actually still doubting the process for some reason, I can bombard you with references and links, so just come and ask me afterwards. So one of the things about code review that's quite interesting is trying to compare the expectations people have with the outcome of the actual code review. And I think this is reinforced slightly by these quotes. You'll notice two of them were talking about finding defects and bugs. And I think that the reason they're talking about that is it's much easier to measure bugs than other things, but there's actually a lot of other subtle side effects and outcomes from code review rather than just thinking of it as a bug hunt. In the paper, Expectations, Outcomes, and Challenges of Modern Code Review, they said that while finding defects remains the main motivation for reviews, reviews are far less about defects than expected and provide additional benefits such as knowledge transfer, increased team awareness, and creation of alternative solutions to problems. So what they actually done in this is research was done in partnership with Microsoft Research. It might have been just Microsoft Research, I'm not sure. But they took some teams at Microsoft, they quizzed the developers beforehand, questionnaire rather than the quiz. So they were asking them why they're doing code review, what they're expecting to get out of it. And the top result was finding defects in codes. Most of them said that's why we are doing code review. But actually, when you look at the, and then after the code reviews had happened, the research team then manually classified hundreds of reviews to manually find out what they thought was the outcome of the review. And this is the results that they had. So they found that defects was only 14% of the time, so that only came in fourth in terms of the actual outcome of reviews. So it's actually a lot more lower down than you would have perhaps expected. I only called out two of the numbers because the paper had a graph in it, and it was quite hard to see the numbers, but they explicitly mentioned those two numbers, so that's why I only have them. But the order is at least correct. So yeah, you can see above defects you're getting code improvements. So the difference between defects and code improvements is the code submitted for review was perfectly valid and worked, but maybe it wasn't the optimal solution depending on your context. Maybe it wasn't performant enough, or maybe there was an API they could have done it in a more elegant way. I'm not sure. There's tons of options. Then understanding was a shared understanding in your team about what is going on with the code base. So if you're not actually reviewing changes as they're coming in, the only way you really find out what's going on, is by looking at your Git history, which I don't think is particularly fun, or you just are trying to use something and you're like, oh, this function's changed, that's kind of annoying. So yeah, it's just about making sure there's a shared understanding and everyone really knows how the project is developing and evolving over time. And then they even found that social communications, which is obviously a very important thing in any team or community, was also rated higher than defects. So with these sort of goals in mind, if we're thinking about, rather than thinking about looking for a bug hunt in code review, we've got to think about how we can maximize all these other benefits as well. I mean, obviously finding defects is still an important part of it, but we shouldn't really focus on that because it doesn't seem to be the main actual outcome. But in code review, we definitely have two distinct roles. You have the author and the reviewer, or you can have multiple at either side of the review process. And if I go back to why a lot of people seem to have a negative view of code review, I think it's often because the actual code review process comes along as almost an adversarial, like you're working against each other rather than together. Like you want to get your code merged, but this person is just getting in your way by giving you like feedback. And I mean, it's kind of a tricky problem to solve this. I'm not really sure why it happens. I think it's definitely more prevalent in some situations than others. And people that tend to be more experienced with code review are quite open to the feedback, and it works a lot better. But I think one of the reasons we maybe see this is I don't like the name for it. I don't like code review as a name. I don't realistically think we'll manage to change it because that ship has sailed. But I, at least in my head, I like to think of it more as a code discussion or a code collaboration. Just like thinking more about how we can work together as a team, and it becomes an iterative process that you're both involved in. Yeah, so it's just really about collaboration and coming up with a better solution together. You both essentially have the same goals in the long term, although it can sometimes seem a bit of a conflict at the time when you're trying to figure out what the best solution is to reach that goal. So what I'll do now is I'm just going to take a look at authoring changes, and then we'll go to looking at reviewing changes after, and just a few bits of unsolicited advice, I suppose, from either side, and you can pick and choose which you think is useful. This first one I think is really important and perhaps overlooked, because you might think that this comes before the code review process, which it does really. But it's always important, especially in open source projects, to talk about what you want to do first. If you don't have an issue or something describing what your goals are and you've not discussed it with the maintainers, then you don't really know if it's even applicable or relevant to this project. Obviously, this is something that you can judge yourself. If it's a typo, that's a no-brainer. You should just send over a pull request. Or sometimes you might find that you can express what you want to describe in code better, but you just have to be prepared that your pull request or your code review might be rejected just because you haven't actually made sure everyone's on the same page. And I think it's also important in the in a work environment, you would expect to have like a requirement description or something before you start working on the code. So it's just making sure you know what you're doing before you write it. It's always good to adhere to the project guidelines. This is pretty obvious, but a lot of people don't actually tend to look for them. This is also perhaps a problem with the projects where a lot of them either don't have them or they make them too hard to find. But you can always take a look at see how the project is working in general, look at other reviews which are waiting or commits that have been merged. Just try and fit in with how they're working, and it makes the process a lot better. So if they've got a good, if they're always like adding tests and documentation with everything, and they're testing on different platforms, then it's always good to make sure you're doing the same and fitting in with their development style. Providing context is really important with your commit, or with your change, for review. I find that reviewing code can be really quite difficult. Often you'll receive a diff for a project that you've maybe not looked at for a few months. So you need to like bring back the mental context of what the project was doing before, and then figure out from this diff what they are trying to do now, and just trying to get that all together in your head. It can be really quite tricky. So you can get around this by writing good commit messages, good pull request descriptions. Just why are you making the change? What do they want? What does it do? Just try and be as descriptive as you can and help them out. And if you're missing the context from this image, by the way, it's a acoustic guitar tuning peg. I don't know why. This is sort of related to the previous slide in a way, keeping your changes small and contained. This is about limiting the context required. So you don't want somebody to have to understand the full breadth of a project to necessarily review something. You want to be doing a small change and keeping your change focused to what the actual topic is. Some people like to do like a 2-line fix in a file, then they'll send you over a 1,000-line diff as they've went around moving things around, sort of thinking they're tidying them up. And that may be perfectly acceptable, but it's better to actually submit these in 2 different review requests. And this tweet I seen a while ago, and when I was preparing this talk, and I just noted it down. And it's basically saying code review, 10 lines of code, 9 issues, 500 lines of code, looks fine. And for this, it's basically, some developers might look at this and think, okay, I'll send a bigger pull request. It sounds like an easy way to get my code merged. But that's definitely not the right way to think about it. And I think the reason you get more feedback on a smaller change is basically it's much easier for the reviewer to get that change into their head and just really get their brain wrapped around it. Whereas if you're trying to understand a much larger change, you end up missing things because you're focused so much on the overall impact of it that lots of subtleties will be missed otherwise. And this has always been kind of a gut instinct for me. The smaller patches were easier or more efficient to review. But there's actually quite an interesting paper. This one is investigating code review quality. Do people and participation matter? They do. And they found that larger patches lead to a higher likelihood of reviewers missing some bugs. So it's great. As I said, I think this is a fairly self-explanatory and obvious one. But it's good to see this is backed up with data, because they spent some time looking into the public Mozilla bug tracker, and they merged it together with the Bugzilla. I can't remember what Mozilla used for bugs, but with their bug tracker and their reviews, and they combined the two to then find the trends of the bigger patches were introducing more bugs and so on. So yeah, smaller diffs are good, touching less files are good. When you actually submit your review, I think it's good to think about that as being the start of the conversation. You'll find that some people will submit a review and they'll wash their hands of it. They'll say that they're done. So they'll send it over and they say, okay, can you merge this, please? Merge this, I'm done. And that just really shuts down the conversation. It's much better to send over the code and say, hey, can you have a look at this and tell me what you think? You're basically inviting feedback and making that feedback loop much clearer. I've had plenty of pull requests and things where people are just do not want the feedback at all, and it just breaks the whole process, and it just eventually you just find it stalls and things don't really progress from there. One handy trick I find when you're opening this pull request, it's actually, or I'm going to keep saying pull request, but I just mean code review in general. I'm not specific to GitHub at all. But yeah, when you open this request for a review, I quite often like to go and actually do a quick review myself, so I'll go and scan it on GitHub or on Gerrit, and I find that I often find mistakes in my own patch at that point. I'm not sure why. I think maybe it's the change of context from an editor to the code review tool that puts me in the right mindset. So that's just a small tip which I recommend doing. And so when you actually, your change is up, you really need to try and relinquish ownership. So this tweet was a response to the Twitter poll that I ran about how much time do you spend doing code review. And to me, this was just a sign of a really toxic culture. I'm not sure if it's the fault of the reviewers or the authors in this change, or in this case, sorry, or both. It's kind of hard to tell without more context, but it's just, as the author of a change, it's really important to just try and think analytically and subjectively about your change when you put it up. And I think this can be quite difficult for people sometimes. You feel quite protective of it, you're quite proud of it, you get kind of tied up with the, hey, my code works, and then when somebody then starts to give you feedback on it, it can feel quite, I don't know, upsetting. The way I like to think about it is, if you've looked at your code from 6 months ago, you probably find it horrific. So just try and think about the code you're writing today like you will in 6 months. And so really, I think reviewing code is pretty difficult. So the whole thing is about trying to make it easier for the reviewers to review your code and give you feedback. Just try and make the whole process go a lot better. Help them to help you. And then when we look at it from the reviewer's point of view, they're kind of like the gatekeepers for this project, at least for code coming in. So they have responsibility to make sure that the code coming in is good and suitable for the project. And this is sorry. This is just like the authors have the same responsibility to try and make the best contributions they can for the project. And the key thing really is that you want to make sure you're sharing the responsibility. I personally see the reviewer of a code or reviewers as being responsible for the change as the author is. And I think this is where some tools like Git Blame are a bit broken, because that will quite often just get you the author of the change, depending on how the code is actually merged and submitted eventually. Whereas it would be interesting if we could have a better way of integrating with code review tools, and your Git Blame will maybe be like, okay, these 3 people are behind this change, or these 2 people are behind this change. But it's better to share the responsibility, basically. This one is definitely for open source maintainers. So the title here is in reference to a quote, which I don't know where it came from originally, but it says something like, code reviews, sorry, I'm getting my words mixed up. The quote says something like, contributions are like puppies. Everyone likes puppies, but you need to look after them, you need to walk them, and you need to feed them. Similarly with code, when you are given it, you need to make sure it's documented, you need to make sure it's testing, and you need to make sure it works forever. So as a reviewer or a project maintainer, you should really feel like you can quite happily say, reject a change just to say no. Sorry, I can't maintain this, I don't have the bandwidth to maintain this. There was a case when I was working on, one of the projects I maintain is MKDucks, and I had a pull request for that, and the change came in. It looked reasonable, it wasn't very big, but I said to the author, sorry, I don't think this fits in the project at this time. And their response was something along the lines of, all I'm asking you to do is just merge it. And I said, no, actually, you're asking me to make sure this is something that works until we're able to remove it from the project, and that can be quite difficult in open source projects because you never really know what people are using. It's really important that everyone reviews. I think it can be, sometimes people would assume that it's better for just the seniors to review in a project and then the juniors are just writing the code. Maybe you feel like they can't be held responsible for the reviews. And this is actually technically true. There is a paper, and I have lost the reference. I have a paper copy at home, I couldn't find it online. But basically, they found out while senior reviewers were doing a better job at finding defects and giving feedback, the best way for juniors to actually level up and become more useful and become seniors, essentially, was to do code review. So you need everyone to do it. And you've also got to remember there's a whole other benefits coming on, so there's a shared understanding and knowing what's going on. If your juniors don't know about this, then they're always going to stay juniors, I think. And the other thing about if you ever have a split in between who reviews and who doesn't, you can find that that can create the divide between the two sides in this. It can become more of a competition against each other. So just make sure everyone is included in the process. And so one of the ways you can join in more with an open source project, and you can review if you're then also submitting changes. Maintainers will absolutely love you if you just review a few other open pull requests or patches whenever you submit a change. So with everyone reviewing, it's really important to keep them all on the same page. It can be a very frustrating process for a contributor if you submit it, you get one review, and then you update it, then you get another review from someone else, and maybe it takes you back to where you are originally. I'm not sure. So just really try and make sure you've got a shared understanding of what is expected from your contributors. You can make this clearer with review guidelines. You can also have things like review checklists that your reviewers are all using and following as a guide. But you've got to be careful with checklists because you really need to make sure that you avoid anything that can be automated. There are a number of things that you can automate in code reviews, and by this I mean making sure that your code style passes whatever linting you want to use, and you can also make sure that your tests are run. And it's just, if you as a reviewer are having to do these steps manually, you're wasting your time. And it's fairly easy to set these things up with something like Travis, which is free for open source projects, or there's tons of open source tools which you could run yourself as well. And one of the best things about automating this is if you run, say, PyFlakes or PEP8 against the code, and you get a negative feedback there, it's much better if it comes from Jenkins or from like an automated CI tool rather than from a human. If you find that you have your reviewers actually manually commenting on code style, then they're just wasting their time, and it's far more nitpicky and just drives everyone crazy. So the nice thing about using an automated tool is you can actually have a shared hatred of that tool for nitpicking all of you. But really the automation is about removing the bike shed. So for these kind of discussions where people might debate code style, if it's not tested automatically, then ignore that comment as far as I'm concerned. If you want to do stricter style guides about something, then add a new, like a Flake extension, a plugin, something like that. And if you're not familiar with what I mean by bike shedding, I won't explain it right now, but just go to bikeshed.com. It's basically, people will debate the simplest details rather than focusing on the actual real problem at hand. And I think someone's picking a color already. Yeah, so moving on, there's not much to say about this. I have a slide for it just because I think some people will assume it's maybe one reviewer per change, but really I think you should consider or at least try multiple reviewers. In OpenStack, we have many reviewers, but a minimum of 2. So that's, I find it really useful, and I think it really multiplies the benefit from some of these sort of side effect goals that you get from code review about understanding what's going on. And one of the other things that's nice about multiple reviewers is you actually, actually that's a slightly side point, I'll come back to that. When you're reviewing, it's important to make sure you're feeling fresh and that you're doing, so you really want to do frequent and short reviews. There's a paper which is the impact of code review coverage and code review participation on software quality. And they found that code reviews peaked at around 200 lines per hour. A bunch of other papers seem to reach about 400 lines of code an hour is what they suggested. So it seems to vary a bit, but it was lower than I expected. But the important thing is just to make sure you're time boxing this and you're not sort of driving on when you're kind of mentally fried because you just won't be doing anything constructive. Personally, I find my best time for code review is just after I started drinking my strong morning coffee, and I don't know, I'm sort of ready to go, and I've not looked at my emails yet, so I'm not very distracted. And I'll spend maybe an hour or so doing reviews then. When you're giving your feedback in a review, make sure that you are being constructive, and you're giving constructive criticism, and you're also giving praise to people in reviews. It's very easy to get tied up with giving bad feedback to people, as in saying, pointing out all the problems. But it's really nice if you can point out to something that you learned in that code review. And I think it really helps make the process a lot more positive. Interestingly, when I was practicing this talk a few weeks ago, one of my coworkers, I got distracted by an email notification, and one of my coworkers has actually said something on a review I'd submitted. He was like, "Hey, I learned something today. I didn't know you could have a class with just a dot string. You don't need the pass statement as well." And I don't know, it made me feel quite good about it. So then I was more encouraged to try and help share more knowledge in the future. And this kind of follows on a similar line. Make sure you're being polite and aware of the tone when you're talking in code reviews. This can be tricky, and it's very easy if you're in a rush to misword things. But so in this example, for example, if I was sitting next to somebody and I said, "Oh, hey, why didn't you do that?" That sounds reasonable because you can hear my tone. I sound fairly relaxed. But if it's written down, it sounds much more like, "Why didn't you do that?" You know, it's I'm not very good at a mean voice, but you can get the idea. So you can alternatively maybe say something like, "Could we do this instead?" You know, it's just trying to be a bit nicer about how you ask things, and it'll make some of the negative feedback easier to receive. And it's really important to make sure you're asking questions rather than telling. So worse than either of those examples, you would say something like, "You should do this," and just tell them. They might have had a good reason for doing that, maybe you just missed it, so you should always ask. And this one I hope is really obvious, but you should never be harsh and never personal in your code reviews. I think this is probably less of a problem in a corporate environment or a work environment, because there tends to be a good social dynamic between people, or at least a social dynamic between two people, and there's always managers and so on to sort out any problems. But it's definitely more of a problem in open source communities. The Python Packaging Authority has a good code of conduct for basically for projects in general that it covers code reviews. So I'd encourage that you use that. I found out about it because I seen that Cookie Cutter, the Python project, were using it. And I do plan to add it to all my projects, but I've not quite got there yet. So yeah, it's kind of like writing code is hard, reviewing is also hard. So you want to really try and help out the authors of the chain. So again, it's helping them help you. And that kind of brings together the two different sides that I have in this conversation. It's about helping each other to come out with the best result and working together. Automate what you can to save time and reduce that kind of burden of doing automated tasks yourself. And be kind to yourself by time boxing your code review. Make sure you're restricting how long you spend doing it. Something I missed from earlier, but I just remembered, so I'm just going to say it now. One of the real benefits I find with doing reviews is that you can actually you can learn a lot about a project. So quite often when I'm starting to work on a new open source project and I want to make some contributions for some reason, I'll actually start doing reviews before I ever submit something. I'll be fairly careful about my feedback because I don't really understand what's going on, but you can quite often make useful changes and you start to see the benefits of that shared understanding and the shared learning in the process. So it's a great way to become familiar with the project, is to look at the reviews of what's happening and see what the current reviewers are saying and see what they're expecting from other people. And also, it's incredibly useful if you can start reviewing like that as well. when I told people about this talk, a lot of them sort of asked me, was I going to do a comparison of different code review tools? Like what's the best thing to do? Personally, I find that's not very interesting. If you want to look at screenshots or read the documentation about these, that's fine. And really, I'm only qualified to talk about GitHub and Gerrit. I use them extensively, but I know of the others, and I'm sure there's a whole bunch more I don't know about, but I've never really used them. The one thing I think you should really expect from your code review is to make sure you're reviewing before the merge. So rather than, say, committing directly to master in a GitHub repo, or sorry, in a Git repo, make sure that you are having somebody review before that happens. So that could be in a pull request on GitHub, or in a sort of a Gerrit code review, for example. The reason for this is the feedback loop is just too delayed if you try and review after it's been merged, and the effort to actually take this feedback and make updates is just much harder. So you'll find that people will do the review and they'll say, oh, we should have done all this, but then eventually it gets forgotten about and no one does it. So you need to keep people motivated and only let the code in after it's been updated for this feedback. But to quickly talk about the two that I do use. GitHub, most people here, I imagine, probably know, so I'll say very little about it. But it's got a very loose and undefined workflow. The labels are kind of useful for like triaging and things, but it's actually quite hard to do any kind of detailed or complicated workflow in your code reviews. It's also got a simple UI, which works quite nice, but some things would be very hard to do. For example, if you wanted to consider doing multiple reviewers, you'd have to have some kind of strange convention to make sure two people had looked at it, and yeah, it just wouldn't really work that well. But yeah, everyone has GitHub, which is a great benefit, and it's also very easy to use and quite appealing as well. Gerrit, on the other hand, is pretty much the opposite to GitHub. It's open source, it's kind of ugly, it's hard to use, but you have very defined sort of workflows and rules in it, and you can do like much more things, like you can have multiple reviewers, for example. When people do a review in Gerrit, they'll explicitly give a vote, so you'll write your comments and then you'll pick like -2, -1, +1, +2. Well, they actually, I mean, they're fairly obvious that they're negative and positive. But the nice thing about that is you can actually give some feedback, which is like, oh, I spotted this typo, but it doesn't really matter. I'll still like give you a positive review, but if you happen to be updating this for some other reason, it'd be good to take that into account. So it allows you to give like the sort of the small feedback, which is useful to have, but not be like a real nitpicking person and block the review just because of that. One of the really interesting things about having all of this data attached to Gerrit is there's a huge amount of information out there online, and this is one of the things that I'd quite like to do at some point. So this is kind of I'm looking for like-minded people, I suppose. In OpenStack, for example, there are around 330,000 reviews in the Gerrit, I think. I can't remember. It's number is going up all the time, obviously. And you can pull down all this data. It gives you like 20 gig of JSON or something. But I'm sure there's something we can learn in there, and maybe we can have some kind of feedback loop. And there's a whole bunch of other projects are using Gerrit in the open, so like Android uses it, WordPress uses it. So maybe we could, I don't know, I'm sure there is something to be learned there, or you could just have fun looking at the data and sort of making pretty graphs. Yeah, I think it'd be quite an interesting thing to do. Yeah, and that basically wraps up my thoughts about code review. I'm happy to take questions. These are my contact details. And sort of related, we're going to do an OpenStack open space tomorrow. So if anyone's interested more about the OpenStack sort of code review workflow, they could come and ask there or just bug me afterwards. Yeah, otherwise, thank you. One thing to note, if you're looking at that, the O in Dougal is a 0. I should have picked a mono font for this one.
Hi there. Great talk. I wanted to know, as a beginner who's working on a project alone, what's a good way to find people to review my code?
Yeah, that is a very difficult problem. It's kind of the eternal problem of, say, an open source project is how do you get more people to look at your code? How do you get more people to use your code? I had wondered if there was some way we could have like a a way of networking people that are working sort of as individuals, and we kind of have a loose agreement to try and review each other's code. That could be quite interesting, and it would also get more people involved. But yeah, I don't really have a good solution there.
All right, thank you.
Hi. I wanted to ask you, do you think that reviewing kind of meta issues, is like you're rejecting merges in terms of, because the commit messages are not clear enough or the commits are not squashed, is kind of being too picky, or it makes sense in the environment?
I think you just need to basically establish some clear guidelines in your project. So in most of my side projects, I wouldn't be too picky about commit messages, but in OpenStack, people actually, and that's one of the nice things about Gerrit, is your commit message is actually a file that comes up for review. So you review people review commit messages as well and make sure that they are useful. I think there's definitely some value in it, but it depends how good everyone is with their sort of keeping their Git history nice and clean.
Hi, thanks for the talk. I also happen to work on OpenStack, so I was wondering, maybe it's just me who misses in the review comments. For instance, there's a large patch set that's in progress for a review, and there's interesting discussion, deep analysis. There's one interesting comment at patch set 25. It's a long paragraph, and then it's just buried in there. On a mailing list-based patch workflow, you can link to a specific large comment. However, in Gerrit, it's just buried and sitting in there. And like 6 months later, if you want to refer to it, again, you have to link to the review. And then there's like a whole bunch of 25 CI jobs listing their status. So it's just very messy.
So yeah,
how do you handle that?
I mean, this is a specific problem with Gerrit, I think. So for people that don't know, when you submit a change to Gerrit, someone then does a review, and then you submit another change. The comments they added on the first revision are hidden. So sometimes you might actually do another review before you see the comments, so you need to actually go and look for them or spot the email notification or something. Yeah, I think it's just a problem with the Gerrit's UI. It needs to expose this better. And actually, I found out recently you can search for all your comments that are in draft, which were never submitted. And I've got a whole bunch of review comments which I thought I had submitted that are just sitting there. I found this last week, so that was a bit of a nightmare. I was like, oh, that's why they didn't listen to that.
Yeah. Thanks. Yeah, it's more of a whine, I guess.
Yeah.
Okay, any other questions?
So I was just wondering what your thoughts are on code review versus pair programming.
Yeah, so this is quite an interesting one. I think so I work remotely for Red Hat, which means pair programming is a slightly different thing in that we sometimes do it on sort of sharing a screen terminal and maybe a voice chat at the same time. And that can work quite well, but it means I've not done a whole lot of pair programming, essentially. I think that you can basically get the same result out of the process, but if you can, so in OpenStack at least, we still need to have other reviewers just for the simple fact that the change won't be merged until you have enough reviewers. So if you pair program it, it doesn't necessarily help you out on OpenStack, but I can see that in some situations you could just replace code review with that. I mean, if there's only 2 people working on a project, then there's not much point doing a formal code review if you're doing pair programming. I think the result could be the same. But yeah, it'd be interesting to know if anyone's got experience like comparing the two, which one they find more effective.
Thanks. Yeah, just a short response to your question, because where I work, we have a signee for code review per week. So before we start working on a new feature, for example, we come together and discuss the implementation. So you avoid having feedback after 3 days of work saying, yeah, this, you know, I don't agree with your implementation or your choices. Yep. So that, yeah, I found it to be really useful to work on a feature together in that way that you plan it together and discuss it before you actually submit your pull request.
Okay. Yeah, no, that works very well. I think, again, this is maybe an artifact of the fact that I'm a remote worker, but what I quite often do is I will put my code up for review very early on, and in Gerrit you can mark it as work in progress. So that allows people to have sort of a rough look at it from a high level, but not do a proper review, and then you can maybe get some feedback a bit earlier, which is another good approach to that, to sort of avoid wasting, say, 5 days or 3 days development. But yeah, if you're doing sort of Scrum meetings, it's always a good sort of time to bring up these kind of questions as well, I suppose.
Anyone else?
Thanks for the talk. Did you maybe try to implement trunk-based development, and did you have experience with that and code review?
Trunk-based development is just when every change just goes straight into.
Yeah, everything goes to the master. It's
okay,
like
so that's
small
essentially
changes all get.
That's essentially what happens in OpenStack. Every change goes directly into the master branch unless you're backporting to a previous release, something like that. So yeah, I guess we do that, and it seems to work pretty well. I've never really been a fan of the long-running branches. I find that they cause more problems, which I guess is the alternative. But I don't know. I'm not sure if I'm missing something else about trunk-based development.
Okay, and what size are your average commits, like in lines of code?
That's a good question. If I look at this data in OpenStack, I could tell you. I guess I like them to be a couple of hundred lines at most. Occasionally, if you're moving things around, you can end up with really big changes, but that tends to be a bit easier to review. Yeah, I'm not sure. I would have to look at that and see.
Okay, thanks.
Hi, thank you for the talk. I wonder if you have some experiences or ideas or comments about reviewing different things than code. Like, I don't know, in OpenStack we have blueprints and specifications, and sometimes code style changes and so on.
Yeah, yeah, I think it can be good, but you've got to be really careful. And this is a problem I think is happening in OpenStack. So when you want to, in some projects, when you want to make a change, there's basically a repository with just restructured text files, and you do a submit with a document describing what you want to do. But the feedback process in that tends to take a really long time because people really start to go into far too much detail on the specs. So I think that tends to not work so well for some reason. I mean, documentation, I guess, is a bit more like code, and that seems to be fine because you're actually documenting what something does. Whereas when you're reviewing this spec, a lot of people are trying to interject how they think it should work. And it almost gets to the point where people are debating the implementation, and to satisfy the code reviews that you're getting, you almost need to write out pseudocode for everything you want to do, and it just becomes this like a big duplicated effort. And I think that's why we've seen a lot of OpenStack projects move away from this like really detailed spec process, or at least they've got something more alternative for smaller features.
Hi, great talk, by the way. I just wanted to ask you something. You stated, and I totally agree with you, that code review is not just a one ping pong thing, but it's just a dialogue, a continuous dialogue. But where do you draw the line? So how far do you go with this dialogue in order to either reject a pull request or merge the pull request?
Sure. So I guess it depends on the situation, and I mean, you have to really define it based on your project. If you're a sole maintainer of the project, then you can simply think, do I want this change? Do I want to maintain this change? And then draw the line there. But if you're working in a company, then you're probably more thinking along the lines of what does the business need? Or in a larger community, you're thinking about, you've got to put on your community hat and think, what does the community want? Does this match the community's expectations? It might not match what you want exactly from a feature, but maybe more there. So there's not really a simple way to do that, I don't think. You've just got to make sure you're taking into account the group that you are working within.
Okay, thank you, Dougal. So that's lunch. Don't forget about the massages. So that's right outside the PyCharm room. And a big round of applause for Dougal.
Thank you. Thanks.